Yes, students, in this session, let us discuss about the coplanarity of the two straight lines which are in a general form. Yes, as I told, the conditions for coplanarity of two lines whose equations are given in the form of general form. Earlier, we discussed about when the two lines are in symmetrical form. One line is in symmetrical form, other line is in what? General form. Now, we shall concentrate on the what? Two lines which are in general form. Then how they are? Let the two lines be A1x, B1y, C1z plus D1 is equal to 0 is same as A2x, this is B2y, C2z plus D2, okay? You call this as equation 1, right? Equation 1. Now coming to other line is A3x, this is B3y, C3z plus D3 is equal to 0 is equal to A4x, B4y plus C4z plus D4, you call it as what? It's second equation. This is first line, this is the second line. They are given in the form of general form. Yes. Now, when the two lines are in general form, when 1 and 2 are coplanar and non-parallel vectors. Okay. Now, 1 and 2 are coplanar, means lying in a what? Same plane, and a non-parallel. Non-parallel means they must intersect at same point, some point. That point will be common to both the lines. Must satisfy the equation 1 as well as what? Equation 2. Followed? So therefore, now when you take a 1 and 2 as a coplanar and a non-parallel, then they must intersect. They must intersect. So therefore, now since 1 and 2 are coplanar and non-parallel, right? Then they intersect. They intersect each other. Let P of alpha comma beta comma gamma be the point of intersection of 1 and 2, which implies I can write this one as A1 alpha, B1 beta, C1 gamma, D1 is equal to 0. Next, I can write A2 alpha, B2 beta, C2 gamma, D2 is equal to 0. Next, A3 alpha, B3 beta, C3 gamma, D3 is equal to 0. Next, A4 alpha, B4 beta, C4 gamma, D4 is equal to 0. By eliminating alpha, beta and gamma from these four equations, we get, yes, we have solved in many aspects. Say for example, while solving the system of linear equations, homogeneous or non-homogeneous in the matrices and determinants, how to eliminate x, y, z, how to eliminate alpha, beta, gamma, we know it. After eliminating alpha, beta, gamma, yes, we get the determinant is equal to 0. Yes, what's the determinant? I can write A1, B1, C1, D1. Next, A2, B2, C2, D2. Next, A3, B3, C3, D3. Next, A4, B4, C4, D4, right? This is how you can find out the condition for the two lines to be coplanar. In particular, when the given lines are in the form of general form. So therefore, this is a condition. Then how to, if we show that the determinant value is equal to 0, 4 cross 4, determinant is equal to 0, then it's nevertheless the given lines are what? Coplanar and non-parallel. So now, this is the condition for coplanarity. Sir, how to expand this one is A1 into, neglect this row, this column, right? You know already the definition of cofactor. The cofactor of any element is obtained by multiplying minus 1 power I plus j to its corresponding minor. The same concept. So therefore, A1 into, neglect this row, this column, it's a 3 cross 3 determinant. B2, C2, D2. B3, C3, D3. B4, C4, D4. Right? Next, go with the B1 minus sign. So because this rise in what? First row, second column. Minus 1 power I plus j means minus 1 power. I is first row 1, j is second column, minus 1 whole cube. Therefore it's a minus. Minus B1 into, neglect this row and the second column. Therefore I can write minus B1 into the determinant A2, C2, D2. Next, A3, C3, D3. Next, A4, C4, D4. Next, C1. Now it becomes what? It is in what common? First row and third column. Minus 1 power what? I plus j, 1 plus 3. Therefore, minus 1 power 4. So, therefore, it's a plus. C1 into, neglect this row and the third column. Now, C1 into A2, B2, D2, A3, B3, D3, next A4, B4, D4. Next D1 into minus 1 power 1 plus 4, it's a minus. So therefore A2, B2, C2, A3, B3, C3, A4, B4, C4, expand it. If we show that the sum of all those determinant is equal to 0, nevertheless the two lines which are given in the form of a general are said to be coplanar and non-parallel. Okay? Yes. Now we come across how to prove the two lines which are in the general form as a coplanar. I want to find out the equation of a plane containing them, correct or not? Convert the equations of what? Lines in a symmetrical form. Convert the equation of straight lines in a symmetrical form. As we have know it already in symmetrical form, how to find out? Then you solve it. That is how you can find out the equations of the corresponding. Followed? So therefore, now let us recall this concept while discussing some example on this. Yes, students, let us recall the concept of how to prove the what? Two lines which are in a general form as a coplanar. I have taken two lines which are in general form. I have to show that they are coplanar, first and foremost condition. First question is, now you write down, the condition for the coplanarity is A1, B1, C1. I have to show that is equal to 0. Now A1, 0, 2, yes, now 1, 0. Right, next, 3 into, yes, now 3, 2, 5, minus 1. Next, 2 into 1, 4, 1. Next, 1, minus 3, 2, 4. We have to show that is equal to 0. So therefore, I can write this one as 0 into any determinant is 0, right? It's a mere waste to what? Expand it. Why 0? Yes, minus 2 into, okay, minus 2 into, neglect this row, this column. I can write 3, next 5, next minus 1, next 2, 2, yes, 4, 1. 3, 5 minus 1, 2, 4, 1. Next 1, 2. Yes, 1, 2. This is 4. This is 4. Right, followed? Next, plus 1 into, I can write plus 1 into the determinant. What's the command? Neglect this row, this column. 3, 2 minus 1. 3, 2 minus 1. Next 2, 1. 2, 1. Yes, 1. Next 1 minus 3, 4. Yes, plus 0 into anything is what? 0. No need to write. Once again, 0 into anything is 0. 2 into minus 2 into 3, 5 minus 1. Yes. Next 2, 4, 1. Yes. 1, 2, 4. Okay, correct. Now 1 into. Yes, neglect this column. 3, 2 minus 1. Next 2. Yes, 1, 1. Next 1 minus 3. Yes, 4. Right. Now expand it. Now 0 into anything is 0. No need to write. Now once again you expand this one as I can write 3 into 16 minus 2 minus 5 into, you know how to expand 3 cross the determinant. 5 into 8 minus 1. 2 into 4, 8. This is minus 1. Minus 1 into, yes, come on, 4 minus 4. Plus 1 into, yes, 1 into, this is one determinant. Next, 3 into 4 plus 3 minus 2 into 8. 8 minus 1. Next, minus 1 into minus 6 minus 1. Now, this is nothing but I can write minus 2 into, yes, now it's a 14. 3 into 14. Yes, now 42, right? So, therefore, now 42 minus 7, 35. Yes, 0. This is what? Next, 1 into, yes, come on, 7. 7 into 3, 21. Next, 14. Next, plus 7, right? Now, this is nothing but minus 2 into, now 42 minus, this is 7. Now, next, plus 1 into, yes, now 21. This is a 28. 28 means what? It's a 14, correct? This is nothing but minus 14 plus 40. Yes, exactly, we got it, is equal to 0. Hence, we can say that the given lines which are in a general form are coplanar. What they are? Coplanar. Followed? Now let us find out. Look, now 1 minute. We have to show that these are what? Representing an equation of a plane. Means I want to find out the equation of a plane containing these lines. We have shown they are coplanar. There must exist a common plane containing these lines. Before that, I told how to find out the equation of plane containing this. First, we have to convert them into symmetrical form. Then we have to go for a point of intersections of a line and what? Planes. Okay. Now let us see. Let L be the line of intersection of two planes. What is that? 2y plus z is equal to 0. If you consider them separately, they are planes. 3x plus 2y plus 5z minus 1 is equal to 0. Yes, let L, M, N be the DCS of a what? A line. Let L be the line of intersection of two planes. Planes means they have a normals. Without a normal, they cannot identify the planes. let small l m comma n be the what? DCS of a line which is always the perpendicular to these two planes. Means line of intersection of two planes means if it is passing through what? You take a what? Any book, the spiral binding is spiral is nothing, spring is nothing but a 3D line. So therefore, now that 3D line, that is spiral, is nothing but a line. That line has a what? DCS L comma M comma N. That line is always perpendicular to the two planes. So therefore, now let us start. Let L comma M comma N be the DCS of a line of the line L, which is perpendicular to the planes, which implies, therefore I can write it is L into 0, M into 2, yes, N into 1 is equal to 0. Therefore, 2M plus N is equal to 0. You call it as what? 3. Next, with this one, 3L plus 2M plus 5N is equal to 0. You call it as what? 4, right? Why? These are the lines. Now solve 3 and 4. Solve 3 and 4. Solve 3 and 4. So therefore, solving 3 and 4, you get what? L, you get M, you get N. Start with the middle term coefficients. Now here also 2, here also 2. Go in the right side, it's a 1. Next what? 5. Next, you start with what? Come on, L, this is 0, here is 3. The first and last is same. Once again, now 2M, start here, 0 into L, start with M coefficient 2, here M coefficient 2, N coefficient 1, N coefficient 5, L coefficient is 0, L coefficient is 3. First and last must be same. You have to go just like a AD minus BC. Therefore, L by 10 minus 2. M by 3 minus 0, N by 0 minus 6. So therefore, which implies, now DRS of a line, correct? DRS of a line is equal to, I can write 8, this is 8, 3, 6, that is minus 6. These are the DRS of a line. Now we got the line. So what's the condition? To write a equation of a plane containing these two lines, first of all you have to convert the first two lines in a symmetrical form. To write a equation of a straight line in a symmetrical form, it must be aptly in x minus x1 by L, or x minus x1 by A, y minus y1 by B, z minus z1 by C. We got it ABC, right? Okay. Now I want a point. What I do is, after solving this, I got it. Now any line, so denominator is nothing but a DRS. They are not a DCS. What are the DRS? Any three real numbers are said to be DRS of a line. They must be proportional to with what? Direction, cosines. Direction, cosines. Therefore, now 8, 3 minus 6. 8, 3 minus 6. Okay. Now I want a point. What I do is, now for point of intersection, now put z is equal to 0 in 2y plus z is equal to 0, which implies y is equal to 0. Put z is equal to 0 in this line. You have to 3x plus 2y minus 5z minus 1 is equal to 0. So therefore, I can write 3x. Already we got it 0 here. This is 0. We made it 0. This is equal to 0. X is equal to 1 by 3. Therefore, they must intersect. What I told, when the given lines are in a general form, a1x plus b1y plus c1z plus d1 is equal to 0 is equal to a2x plus b2y plus c2z plus d2. You call it as a 1, correct or not? Next, so next one is a3x plus b3y plus c3z plus d3 is equal to 0 is equal to a4x plus b4y plus c4z plus d4. So therefore, when they are coplanar and non-parallel means they must intersect. They must intersect. So therefore, I am finding the point of intersection of these two lines, correct or not? So therefore, now I got a point P is equal to point P of x1, y1, z1 is equal to, what is that? Yes, 1 by 3, 0, 0. Right? These two lines are intersecting at this point. If you want, you can substitute. That certainly satisfies. So therefore, now you see, substitute this point here. Now 3 into 1 by 3, 1. This is 0. This is 0. 1 minus 1, 0. What we got, the point of intersection is correct. Now let us write the equation of a line in a symmetric form. Now equation of a line L symmetric form. Symmetric form is x minus x1 1 by 3 by, yes, 8 is equal to y minus what? 0 by 3, z minus 6 by z minus 0, 0 by minus 6. This is the equation of a line in a symmetrical form. Understood? So therefore, this line must be satisfied by these two lines. Then we can say that they are intersecting. Okay, let us see how this is. Now let us find out the point of intersection of the lines of these two lines, first line and as well as second line. Now for point of intersection of lines, to find the point of intersection of lines, this as well as this, let us take this as a what? Come on, lambda. Now this is a line in a symmetrical form. So therefore let x minus 1 by 3 by 8 is equal to y minus 0 by 3, z minus 0 by minus 6 is equal to lambda. Right? So therefore I can write this one as, now x minus 1 by 3 is equal to 8 lambda. Therefore this is equal to 8 lambda plus 1 by 3. Next y is equal to 3 lambda. Next z is equal to minus 6 lambda. So therefore now point of intersection BQ is equal to, yes, 8 lambda plus 1 by 3, that is 3 lambda minus 6 lambda. This is, now this must also satisfy 2. This is 2. Let us see how we can satisfy this. So now coming, this one is now satisfy. Now you substitute in what? 2. So these are the planes separately. Satisfy the planes. If I take separately plane, this one is, that is 2 into, what is that? 8 lambda plus 1 by 3 plus y, 3 lambda, next minus 24 lambda plus 1 is equal to 0. This point must satisfy the planes. If it takes this equation separately, they are planes. Together it forms a what? Lines. So therefore, now I can simplify this. Now 16 lambda, next to 2 by 3, next to 3 lambda, minus 24 lambda. Okay, minus 24 lambda plus 1 is equal to 0. So therefore 16 plus 3, 19 lambda minus 24, 5 lambda. Therefore 2 by 3 plus 1 by 3, 2 by 3 plus 1 minus, that is 5 lambda, okay, is equal to 0. Now 5 by 3 is equal to 5 lambda. This and this get cancels. Lambda is equal to 1 by 3. Now, when this is satisfied the first plane means it also must satisfy what? Second plane. Means second plane means same value of lambda we have to get. What is the lambda here? Now, this you have to substitute in the what? Second plane. X minus 3y. Yeah, that is 8 lambda plus 1 by 3. Next, 3 lambda into this minus 9 lambda. Next, 6 lambda plus 4 is equal to 0, right? This you substitute here, x 8 lambda plus 1 by 3, yes, correct, minus 3y, 3 lambda minus 9 lambda minus 6 lambda, that is what? Minus 6 into 2. Here little change is there. I can write this one as, now coming this one is, you substitute this point here in the what? Here x minus 3y. X minus 3y plus 2z plus 4 is equal to 0, right? Substitute this point. This also must satisfy this plane. Now 8 lambda plus 1 by 3 minus 9 lambda. Next what? 12 lambda plus 4 is equal to 0. Therefore, what I can write is, look here, 8 lambda minus lambda minus lambda minus 12 lambda minus 13 lambda, okay, 1 by 3 plus 4 is equal to 0. So therefore 13 lambda is equal to 13 by 3 cancels, therefore lambda is equal to 1 by 3. Yes. Now here also lambda is equal to 1 by 3. Here also lambda is equal to 1 by 3. It means that this common point satisfied by the two planes. Now we get the point of intersection of these lines, okay, with the planes. So therefore now Q implies, what is Q? Q is equal to, take what? Lambda is equal to 1 by 3, substitute. This becomes 8 by 3 plus 1 by 3. Next, it's a what? 3 into 1. 3 into 1 by 3. Now this is minus 2. So therefore Q is equal to 9. Therefore 3 comma 1 comma minus 2. You take this as x1, y1, z1. Okay. Or else x2, y2, z2. As you please. Now we got at this point. As we have, now we have found out the point of intersections. And we have shown they are what? Coplanar. All are passing through same point. Now we have to find out the equation of a common plane containing these two lines which are in a general form. As we have discussed earlier, we have dealt in earlier, when now two equation of a plane containing the two lines is given by a1x, okay, a1x plus b1y plus c1z by AL plus BM plus CN is equal to A2X plus B2Y plus C2Z by what? A2L plus B2M C2N. Followed? So therefore now what I write? The equation of a common plane. Now let us find out the equation of a plane containing the lines. Next question is, equation of a plane containing given lines is, yes, you can go to this one is, these are the lines a3x, b3y, c3z plus d3 by a3 into L, b3 into M, c3 into N is equal to, yes, I can write a4x, b4y, c4z, d4 whole divided by a4l, b4m, c4n, right? Now coming this one is, I can write this one as, yes, a3x, what is come on, this is 2x plus y plus 4z plus 1. Now so here 8, 3 minus 6, 2 into 8, next 1 into what? 3, next 4 into minus 6 is equal to f4, this is x minus 3y plus 2z plus 4 whole divided by a4 into L. This is 1 into 8, 1 into 8. Next, minus 3 into 3, right, into 3. Next, 2 into what? Minus 6. 2 into minus 6. This is the what? The equation of plane containing the lines which are given in the form of general. Okay, this is how you can show that when the what? Lines are given in the general form as coplanar. First condition is, first and foremost condition is determinant 4 cross 4 determinant is equal to 0. How? A1, B1, C1, D1 is equal to 0. Next A2, B2, C2, D2. Next A3, B3, C3, D3. Next A4, B4, C4, D4 is equal to 0. That value is equal to 0. We have proved according to the concept or by giving some examples as a desired. If we show that the value of the determinant is equal to 0, then we can say that those given lines in a general form are coplanar. Next, we established what is that? By using these two planes, we found out that is an equation of a line. If you consider what separate lines, they are planes. If you combine, it's a straight line. We found out the equation of a straight line in a symmetrical form. With these two, with this one line, we express this line in a symmetrical form. Okay, symmetrical form. How? That L be the what? Line of intersection of these two, okay, planes. Then that line will also have a what? DCS L, M, N. That line will be always normal to the what? Given planes. Therefore, we wrote the what? Condition for the perpendicularity. What is that? A1L plus B1M sub C1N, correct, is equal to 0. Then we solved those two conditions in terms of element. We could get as a DRS 8, that is 8, 3 minus 6. Later, we found out their point of intersection by taking z is equal to 0. We got it point of intersection as something as what? It is some 3, 1 minus 2, right? So therefore, now after that, then we went show that that point also satisfied by these planes. We have proved that after finding the value of lambda. Then after knowing that value of lambda, after knowing that point, then we wrote how to write the equation of a common plane containing the lines. By using this concept, we went a3x plus b3y plus c3z plus d3y, that is a3l plus b3m plus c3n, a4x plus b4y c4z plus d4 by a4l plus b4m plus c4n. This is the equation of a plane containing the two straight lines in a general form. Okay, next one is, yes, in this session we shall discuss about one line lies completely in a plane. Means when a line lies in a plane, it is quite obvious every point on that line satisfies the plane. So therefore, let us take equation of a line in a vector form is line B, R bar is equal to A bar plus a lambda B bar. You call it as 1. And equation of a plane in vector form is R bar dot N bar is equal to D. You take 2. So therefore, now we have to find out the condition when this line lies in the what? Plane. When that line lies in the plane, means every point of the line must satisfy the plane. Solve 1 and 2. Now from 1, 2, So therefore, when one lies into, which implies every point on the line, one must satisfy the plane. What's a plane? R bar dot n bar is equal to d bar, which implies, solve these two. Now, in place of R bar, you substitute A bar plus lambda B bar dot of n bar is equal to d. Followed? Now I can write A bar dot n bar, okay, A bar dot n bar plus lambda into B bar dot n bar is equal to d, correct? So therefore, I can write, so lambda into B bar dot n bar is equal to d bar minus A bar dot n bar. Therefore, lambda is equal to d bar minus A bar dot n bar by B bar dot n bar. Okay, now you take this value, substitute in 1. So what 1 implies? This value substitute in 1. R bar is equal to A bar B bar into D bar minus A bar dot B bar dot n bar. This is a condition. Now what I can write is, yes, R bar is equal to, you take the what, come on, A bar, now A bar into B bar dot n bar plus B, that is B into D bar minus A bar dot n bar, whole divided by B bar dot n bar. This is the condition. This is the what? The equation of the line. Equation of the line. Yes, now students, this is the position vector of a point of intersection of a line and a plane. Okay, sir, this is the position vector of a point of intersection of a line and a plane. You tell me what's a condition. Say for example, in this line equation, he put something, A bar is equal to something, B bar is equal to something. In D, he gives some unknown. Instead of this what, come on, D, it's a what? It is nothing but a scalar. No need to take this as D bar, it's a D only. Now I can write, yes, you can write this one as, now D is a scalar. The condition for a line to lie in a plane in a vector form. This is equation of a line in a vector form. This is what? Equation of a plane in a what? Vector form. So therefore, when one lies into, which implies every point on one must satisfy 2. Therefore, which implies A bar plus lambda B bar dot n bar is equal to D. D is a scalar. Therefore, I can write A bar dot n bar lambda into B bar dot n bar minus D is equal to 0. I can write A bar dot n bar minus D plus lambda into B bar dot n bar is equal to 0. Where lambda is a what? Scalar. For all lambda is equal to 0, you can compare the coefficients. You can write A bar dot n minus D is equal to 0 and B bar dot n bar is equal to 0, right? Now I can also write is equal to D. B bar dot n bar is equal to D. Now it's not a D bar, it's a D, it's a D. So therefore, now this is a condition. A bar dot n bar is equal to D, B bar dot n bar is equal to what? 0. This is the condition for when the one line which is in a vector form completely lies in a plane, it is also in vector form, is a bar dot n bar is equal to e. It's a scalar product is equal to scalar. It's a scalar product is equal to 0. It means that b bar is perpendicular to n bar. Okay, these are the conditions. Yes, then you tell me what is the point of intersection of the plane and the line. Okay, if you want, what you do, you solve this and get the value of lambda, substitute here. That's what. Here only lambda is there. You transfer this one. B bar dot n bar is equal to, so what is equal to minus of a bar dot n bar minus d. Cross multiply. That gives the value of what? Lambda. Substitute. That gives the point of position vector of point of intersection of line and a plane. On this context, let us verify what some problems on this. What is that? Yes. Look here, students, let us recall this concept for the problems. Now, does this line lies in this plane? This also in what? R bar is equal to a bar plus lambda b bar. This in the form of r bar dot n bar is equal to d. Let us write a bar is equal to 3, 0, 3. Next, b bar is equal to 3, minus 1, 5, and n bar is equal to 4, minus 3, 3. Next, d is equal to 3, followed. Come on, verify this condition. What's the condition? A bar dot n bar is equal to d. We have to verify. What is a bar dot n bar? Take the dot product. Now this is 12, 0. Next, this is 9. Yes, 9, this is 9. So, a bar dot n bar is equal to d. Now d is what is given? 4, yes, 4, that is 12 plus 3. Okay, is equal to, now is equal to how much? That is 21. This is not equal to what? Come on, 4. This is not equal to 3. This is, therefore this won't. Then no need to go for what? Come on, b dot n bar is equal to 0. So therefore that line is not lying in the what? Plane. If it is equal to, then we can call it as that line lies in the what? Plane. If you want, you can verify. A bar is equal to 3, 0, 3, and b bar is equal to 3 minus 1, 5, and n bar is equal to 4 minus 3, 3. So therefore d is equal to 3. A bar dot n bar, this is 3. 3 into 4, 12, this is 0 plus 9. Yes, it's not equal. Hence, this line does not lies in the plane. If it is equal and satisfying b dot n bar is equal to 0, then that line lies in the what? Plane. Yes, students, let us verify this concept. This is r bar is equal to a bar plus lambda b bar. In place of lambda, yes, r bar dot n bar is equal to 3. What is your a bar? A bar is equal to 3, 0, 3, and b bar is equal to 3, minus 1, 5, and n bar is equal to 4, minus 3, minus 3, and d is equal to 3. Yes, a bar dot n bar is equal to d, and b bar dot n bar is equal to 0. We have to verify. Come on, a bar dot n bar. What is a bar dot n bar? Come on, this is nothing but a bar dot n bar is equal to 12. This is 0 minus 9 is equal to 3 is equal to d. Yes, we got it. Next, you verify b bar dot n bar. Don't write 0. We have to verify that. B bar dot n bar, 3 into 4, 12. Next, minus 1 into 3, minus 3, it's a plus 3. It's a what? Minus 15. Yes, it's a 15 minus 15 is equal to 0. Hence, we can say that the line 3i plus 3k plus s into 3i minus j plus 5k lies in the plane r bar dot of 4i minus 3j minus 3k is equal to 3. Hence, this line completely lies in the plane. What are the conditions in a vector form? The conditions are a bar dot n bar is equal to d and b bar dot n bar is equal to 0. Thank you.